Okay, and again the x there is going to be 7.5 times 10 to the negative fifth. So we have that, it comes out to 7.5 times 10 to the negative fifth. So that's obviously a small value for our x, and that's our H3O plus or H plus concentration. So that's probably some points right there. But again, they're asking for a pH. And so pH in this case, remember pH is equal to negative log of our concentration H plus. So in this case, negative log of 7.5 times 10 to the negative fifth. Okay, which comes out to 4.13. Okay? Alright, so the next part here, we'll start fresh here, so part C. Okay, what they're asking for is the net ionic equation for the reaction between the weak acid and the strong base. So in this case, it's kind of like a titration, or at least a neutralization reaction. And so net ionic, so that means they only care about what's involved in it. And as we know with sodium hydroxide, this Na plus is not going to be involved. So just like when predicting reaction sections, with strong bases or strong acids in this case, we don't need the sodium or maybe a chloride, for example, like an HCl solution. So in that case, but for the weak acid, like HOCl is a weak acid, the OCl minus that we're going to have left over is important because that can contribute to pH in kind of like a buffer type situation. So that's important. So our net ionic equation then is going to be, so we have our HOCl, which would be aqueous, plus our OH minus, which is going to give us water. So like our neutralization acid-base reaction is talking about producing water when it's H plus and OH minus, and we're going to have our OCl minus left over. Okay, and then next part, they're actually, like I said, it's like a titration, so they're actually doing some calculations with a titration here. They have a certain amount of 20 milliliters of that known 1.175 molar HOCl, and we're titrating it with 6.55 milliliters of 0.435 molar NaOH. So normally in a titration we don't know what the concentrations are. In this case we do, and we're going to have to calculate some information along the way. So the first part, they want to know how many moles of NaOH we've added, and so that's just a question of 6.55 milliliters and 0.435 molar NaOH. Okay, and so remember, molarity times volume will give us moles. So in this case, our moles will be equal to, again, we have milliliters there, so we need liters. Okay, 0.0065 liters times our 0.435 molar NaOH solution. So when we do that, we come out to, looks like 2.85 times 10 to the negative 3 moles of NaOH that we've added at this point. Okay, so this is part I. And the next part, they're asking us for the H3O plus in the flask after we've added that much. And so now our situation gets a little trickier. And I'm going to hold off and start on another fresh one. They give me a 5-minute maximum on this, so we'll stop this one and then we'll start fresh on the next one.